Tetra Pak history starts with a package that did not look like today's milk carton. Coated paper was formed into a tube. Liquid entered continuously. Jaw sealed the tube across alternating directions, and each section was cut into a tetrahedron. The promise was concrete. Replace a heavy returnable bottle with a light package designed together with the machine that filled it. Tetra Pak's company history traces the idea to Reuben Rousing's study of self-service retail and prepackaged goods. Development of a paper container for milk began within Ackerland and Rousing, and AB Tetra Pak was formed in 1950 to commercialize a system rather than merely sell an empty carton. That origin matters because the Tetra Pak carton was not merely a smaller version of an older appliance. It reorganized a familiar task around a new constraint. Liquid food needed a light package that factories could fill and shops could move. The design therefore has to be judged by the routine it changed, the resources it required, and the kind of control it transferred to an ordinary user. The tetrahedron shape followed the filling process. A web of coated paper became a tube. The tube was filled, and transverse seals closed it at alternating angles. That geometry could be made with little material and a continuous motion, turning package formation and filling into linked stages on one line. Mechanically, the important point is the sequence rather than any single part. The user performs a simple action, hidden components translate it, and the product produces a repeatable result. Showing that chain makes the Tetra Pak carton understandable as a working system instead of a nostalgic silhouette, and it fulfills the documentary promise with evidence rather than atmosphere. In September 1952, the first filling machine went to the Lund Dairy Association. Tetra Pak says the dairy began selling 1 deciliter cream packages that November. The first commercial step was therefore small cream portions, not an instant worldwide replacement of every milk bottle. Manufacturing turned the idea into infrastructure. Materials, dimensions, seals, switches, motors, hinges, or containers had to agree every time. A product becomes ordinary only when factories can repeat it, repair networks can support it, and households can trust that the next use will resemble the last. Reliability is therefore part of the historical story, not a footnote. A package changes more than the moment of pouring. Its weight affects transport. Its shape affects crates, shelves, and refrigerators. Its seal affects leakage and shelf life. Its printed surface carries identification and instructions. The carton joined all of those tasks in a disposable object that traveled with the liquid. Inside the home, value accumulated through repetition. One use might seem modest, but the same saved walk, protected food, repaired garment, private song, washed face, shared program, or prepared drink happened again and again. Tetra Pak carton mattered because it attached industrial design to the small schedule of a day and made that schedule easier to plan. The original tetrahedron was memorable but awkward to stack into a rectangular case or line up on a shelf. Tetra Pak records a rectangular cuboid solution in 1959, later named Tetra Brick in 1963. The more ordinary rectangle succeeded partly because empty space is expensive in storage and transport. The cultural meaning followed the practical value. Scarcity, price, novelty, and visibility could turn a tool into a signal of readiness or modernity. That does not mean every family owned the same model or used it in the same way. It means the object became legible to other people as evidence that a household had gained a new capability. Aseptic systems later combined sterilized product, sterilized packaging material, and a protected filling environment. That development allowed some liquid foods to travel and wait without an unbroken refrigerated chain. The claim belongs to the complete process. Paperboard shape alone does not create shelf stability. Scale also changes interpretation. A single surviving object can look quaint, while thousands or millions of similar routines can reshape shops. streets, factories, bedrooms, and expectations. The safest claim is not that the Tetra Pak carton transformed every life identically, but that it helped normalize a new relationship between people, time, space, and a repeatable service. The carton also carries an environmental trade-off. It can reduce weight and breakage compared with glass, but a laminated package combines paperboard with polymers and sometimes aluminum. Collection, sorting, fiber recovery, and treatment of remaining layers determine whether the material becomes another product or waste. Its decline was rarely a sudden mechanical failure. Competing products changed the comparison by offering another balance of cost, speed, space, labor, portability, or status. The older object could keep working while its social role narrowed. That distinction prevents a simple progress story and explains why useful designs often survive after losing their former central place. Modern cartons survive because the core idea remains systemic. Designers do not optimize only the wall of a container. They coordinate material roles, seals, filling equipment, food safety, pallet geometry, printing, opening, pouring, and recovery. The humble carton is the visible edge of a much larger machine. What survives is a design lesson. It made the package, filling machine, and distribution system one design problem. The casing and styling may date, but the underlying promise remains recognizable. When a newer product repeats that promise with different materials or electronics, it carries forward part of the older object's logic even if the original machine has moved to a cupboard, collection, or memory. Return to the object itself. Tetra Pak carton joined a physical mechanism to an ordinary promise, then accumulated meaning through repeated use. Its history is strongest where evidence separates invention, manufacture, ownership, and later memory instead of blending them into one legend. The surviving lesson is concrete. It made the package, filling machine, and distribution system one design problem. New products may change the materials, power source, scale, or interface, but they still have to solve the same human problem clearly enough to earn a place in daily life. To see the change at human scale, reconstruct the routine before and after. Before the Tetra Pak carton, the user had to coordinate more separate tools, trips, waiting, attention, or shared resources. Afterward, part of that coordination moved into the object. The machine did not abolish work. It packaged several decisions into a stable sequence. That is why a modest household product can matter historically even when its individual action looks small. There is also an infrastructure test behind the familiar casing. Tetra Pak carton depended on materials, energy, distribution, maintenance, and knowledge that extended far beyond one home. When those supports were scarce, ownership remained exceptional or the product served a group. When they became dependable, the same object could fade into the background. Ordinary use is therefore evidence that an entire supporting system has become reliable enough to stop demanding attention. The design can be read as a set of trade-offs rather than a perfect solution. It gained control over liquid food, needed a light package that factories could fill and shops could move. In exchange, users accepted cost, space, upkeep, preparation, or a new dependency. Later products won when they offered a more attractive balance, not necessarily because the earlier mechanism stopped working. This is how a durable invention can remain useful and still lose the central role it once held. A final comparison keeps the claim precise. Tetra Pak carton did not reach every household at once, did not remove every burden, and did not become obsolete on a single date. Adoption varied with price, supply, infrastructure, repair, space, and habit. Its importance comes from the capability it made visible and repeatable. It made the package, filling machine, and distribution system one design problem. Remembering that capability explains both the enthusiasm around the original product and the quieter ways its logic survives in newer designs.